Hello and welcome to another video on the Advanced Redux. Euler Gonzalez here. This is a course taught by Steve Kinney, and in today we're going to take a look now at this deeply problem that now actually Redux is solving, specifically create reducers, specifically the reducer and the way how now the reducer is working behind the scenes. What are the things that is using as a way to solve with this particular problem? Why we actually are doing this, right? In today's video, remember, the end goal is to actually be able to describe what is the entire problem that Redux is trying to solve, especially with reducers, and what are the mechanisms that is doing and using behind the scenes as a way to come up with a solution that we are now using behind the scenes, and what this solution provides, what is the problem that those tools actually are solving. Why this is important? Because this is now the foundation of how UI developers is going to provide from 2024 and so on, right? So is we are able to now understand what is the problem that actually UI developers are solving or providing to business, which is not only the ability to create or design system, front-end design systems, but also by using some of these technology, web technologies like the HTML, CSS, and JavaScript, and understand what each one of them actually, what is the purpose of each one of them, as well as to understand now how the browsers works behind the scenes as a way to make HTML, CSS, and JavaScript, all of these files get rendered in pixels on the screen, so we can now have a more deep understanding of that, as well as that despite that I mentioned before, that we have now the ability as a UI developers to design front-end systems, okay, which is one of the reasons why a lot of these top tech companies actually are looking for, is that, hey, good that you know that this technology works. What is the problem that each one of these technology actually solve? HTML, CSS, and JavaScript. You also know is the anatomy of these tools, okay, in the case of HTML, the CSS, and JavaScript, but also what are now the problems that these top tech company are facing when it comes to build user interface, and the reason why, for example, this open source tool like React actually come out in place. So because companies like PayPal, and back when the internet began, right, company like PayPal, eBay, and Amazon, each one of them as a side product, I will argue, engineers that they were working at each one of these company, they need to find solutions to their own particular problems, especially when it comes to design user interface. So for example, eBay has now a public or an open source UI tool that is quite interesting, that it hasn't become so popular as any other UI frameworks that comes before. So Marco is this declarative HTML based language that makes building web applications fun, according to their website, right? But this is something that is still being used, okay? So people, right? So people, this is quite interesting, by the way. So people, so engineers that work at eBay, they realize that building user interface, especially the more and more features that you need to provide, the more complicated and cumbersome it becomes to build, change, maintain, and test, right? So that's why, for example, now a company that came before the second generation, starting from 2000s, right? For example, like Facebook, they realized like, okay, so they hired the top talent back then, and and the most brilliant minds there actually using some of the concepts from the computer science and mathematical backgrounds and that kind of thing. So they decide to say, hey, you know what? In the case of Google, they come up with Angular JS, which is of course is right now is quite deprecated. Is that deprecated, right? They're now actually using is a Angular, plain Angular. Now they look beautiful. Now the kind of thing is like, wow, they're using, of course, is interesting. Despite that they have a great marketing here, right? This particular frameworks now works well is for, or this was designed for enterprise, finance, for example, finance, healthcare. So they build this with that target in mind. And also something that I actually have experience with this, and also another framework like React came around in 2018 as open source, right? If I recall that, React open source date, right? 2013. Okay, there was the initial release, and yeah, right now is on Holy F. They now are in the 19 release candidate. Oh my god. So, what does it mean? People here on Facebook, okay, they actually build this library as a way to solve their own particularly specific problems when it comes to describing UIs. Okay, using is of course JavaScript for that. So why am I doing this quick recap? It's just as a way to be able to describe how do we get here, and especially if you're going to build now user interface, or you're going to be an UI specialist, it's important to understand that as a way to know, as a way to get context, be able to describe that in a very clear and concise way possible, so other people can now understand that, and by giving that context, you also are providing meaning to them, which is one of the role of these senior roles, right? Senior developers, whether it's front-end, back-end, DevOps, seniors. With that, right? So now that we look at how JavaScript works in other courses, so you have now this ability to bundle your data and functionality in the same place, in the same bundle. So we're using is the object-oriented programming, which is great, and how you can now using the prototype or the object-oriented prototype as a way to access to property as a way to access property from another object. Okay, so we can be memory efficient. And when it comes to now using the new latest syntax as a way to create objects, how we can use the new or the class behind the scenes. So okay, good. Now, when it comes to actually handle async operation, because at the end of the day, the entire reason to HTML exists, okay, or the browser to exist, is now it provides us the ability that if you have your grandmother alive, you will ask her how she communicate with their sons or grandsons if they're fighting overseas, right? Or for example, if she is sick, how she notified to their family, right? So she have to have so she have to need she must she she must need to write a letter. Jesus, what happened? Yeah, she must need to write a letter, then send that to someone of trust. So asking someone of trust to send that letter to the postal servers, usually a postman, and then the postman sends that on the postal servers. They're gonna collect all of these different cards, and they're gonna wait until they have a huge chunk to transport that. While doing that, they need to defend that from Indians, robbers, alligators, wild animals, buffaloes, who knows, right? It reaches the destination, so the postal receiver now process that where it needs to be sent this letter. It give it to the postman. The postman deliver to your house, or to whatever part you are, at least in the US. So that's something that takes time. All of these things that I described is something that took a lot of time, weeks and months. And if your mom is sick, by the time you receive that letter, she might be dead. So the browser here, and also in combination with the internet, but the browser here now allow us is to have access, of course with consents and proper permissions, have access to documents of somebody else's computer, okay? And from there, we can now is read that context. So it's not enough with just read that, because at the end of the day, if you can only read something, it's pretty much like you buy a newspaper. You read that, and then you see your pet is discharging. So you see now, so you buy the newspaper, right? And you see that your pet is coming up clear near to your carpet, and is about to discharge it, and before he's doing that, no. All right. So let me actually grab this and then trash that. So most of the time, this is what happened with read data. It's like good, great, stay there. Perhaps I will never go to there unless I need to refresh some content, for example, in this case. But that's the idea. So because we want is to also need the ability to change that document, okay, to interact with the document and change that. And maintain these communications, right? So these companies understand the challenge, Amazon, PayPal, and that, and they decide to take an action upon that. So, for example, for sending money, or for sending or receiving money, or for buying and selling books in the case of Amazon, or for buying and selling stuff in the case of eBay. So the point of that is, because of this, all right, now with this huge background, as a way to understand why this company is doing that and what is the side effects, or this open source movement from this company, because all of these engineers need a way to solve their own problems, so they create their own tools for that. For example, Marco and React. Now we're using React as a way to describe is this user interface. So now moving forward here, we also look at what React is. So React, after all, allows is to describe all of this user interface based on the states. Okay, how that things actually work behind the scenes is also interesting. And when it comes to now actually manage more state, more data. So for example, in an e-commerce, it's like when you need to actually show the orders and the transaction history, or the current stage at where a particular order is currently at, right? Is that order has been dispatched, or is processing, or is actually on the road. Not only that, is to also show product by categories. So all of this data that we need to handle here, it becomes quite challenging to do so. So that's why now, again, developers actually created. There is a developers like Redux, Abramov, Dan Abramov, the creator of Redux, right? The creator of Redux, and now they have maintainers upon that. So another maintainer here, Dan Abramov and Andrew Clark. Okay, is another one. I don't know why he doesn't. Okay. Okay, what? So yeah, so Dan Amabrov and Andrew Clark, right now the maintainer of Redux. Okay, the Redux maintainer is Mark Erickson, right? Yeah, Mark Erickson. As you can see, Mark Erickson. Yeah, he's known as by his Simpson account, right? He's the maintainer of Redux, and he's working at Replay as well, right? Which is this company that is an open source, if I recall that. I think this is the first browser with instant replay. Oh, they're working in a browser. That's interesting. Oh, okay. I think they're doing is this because okay. A browser. A browser to cover, a browser to solve that particular problem, the end-to-end testing. Exactly, a browser to solve that. The majority of the end-to-end test failure are caused by backend issues. Reply Network Monitor help you to find bad requests and inspect that. Okay, that's interesting. Holy F, bro. Holy F, bro. Holy moly. Shit. Oh, for French, trusted by top engineering, Versal, Codesandbox, Metabase, I get it. Apollo. So they're using this Replay. It's a first browser with instant. Okay. Investigate bug and flaggy text with perfect reproducibility. How much does it cost? No? What? This is a what? I don't think this is an open source tool. This is an open source? What the what? Careers? What? Starting with a standard PhD and continuing through 10 years at Mozilla, where he worked at JavaScript virtual machine optimization and developed a precursor to Replay. Oh my god. He's a nomadic adventurer and enjoys sailing around Polynesia and van travel in the western US. What the heck? What? Okay. Yeah, but what? How do they make money? How in the F do they make money? What the hell is it? With the Replay browser. Okay, that's quite interesting. I think I misunderstand that he was working at Relay. Relay is another Relay. My bad. Relay is an open source tool for GraphQL. It's an open source tool from Facebook, the GraphQL client that scale with you. Oh, okay, bro. Interesting, but okay, Replay. Okay, okay. This is a browser for end-to-end testings. Interesting, interesting. Very, very interesting. Very, 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 very interesting. Okay, okay, cool, cool. So yeah, Mark Erickson is currently the maintainer of Redux. Okay, so yeah, because we're going to use Redux, and after all, Redux is just a way to actually help us to keep track the state change by giving us is a time travel debugging where now we can provide we can follow is the Flux architecture. You have the action, dispatcher, and the state. This is just as a way to give predictability when it comes to update the state in a particular object. Now we're talking about JavaScript. So anytime you want is to know when an object change, or in this case, when a particular piece of state in React change, you need to have an observability here. What's going on here? Okay, so Redux provide this, and these Redux advanced toolkits or the Redux RTK, what it says like there is a lot of monotonous things that we can automate that. So one of the or the main three problems that Redux actually solve is that the ceremony required to actually set up that particular pattern or this particular architecture, which is the Flux architecture, as a way to know how this data is going to be updated and have this ability to time traveling of all of those state change. All right, let's go to now simplify that process. Okay, the other is let's go to implement now TypeScript because it's not an easy things to do, and also let's make adding frameworks or middlewares to the Redux something that is much easier to do, as well as handling is async operation, which is one of the things that when you're building an application, it is required for you to do that. So again, I know that was a lot. It doesn't matter if you don't follow to me. I'm sorry to actually taking you to this entire journey. All right, I did that mainly for myself as a way to improve my communication skills and understand how do we get here and make sense of all of this. So that's great, that's beautiful. So what we really care about in today's video is that how we're going to now to look at the particular problem of Reducer and what is the problem that create Reducer, that particular function actually solve. What are the benefits of using that particular function? So, in other words, this is a very small course, but this particular course that is small actually lead us is to a more deeper computer science problems, a current computer science problems. So this introduction is just what I did, okay? As a way to understand the Redux toolkits, which is something that we're going to talk about, that type hooks and async requests. So Redux toolkits is this nice convenient library that allows us to implement the Flux architecture. RTK is now saving a lot of his time by solving those problems that I already mentioned. So the way to do that is by first creating a slice, okay, where you can pass is now a reducer and a name of the slide and an initial state, okay, and then you're going to get is create actions as well as action types, your reducers, and the states. So when we take a look at what is doing these things behind the scenes, especially first with the create actions, which is simplifying is the way of how can we now create these kind of objects that follow this particularly flux architecture or this particularly pattern, okay? So what we're going to define is the type of actions that we want to perform to our data, okay? And the payload is if it has some, it actually generates the type for us, and then when we actually now perform the state or update the state, we use is using is the create reducer, which is a fancy function. This is a function that takes a state and an action to generate a new bit of a state, right? So here with this the create action and the things, this reducer, because anytime you do that, remember, following is this deterministic way of how the state change using the flux architecture. It has the action, and then we have the reducers, which is something that I explained that, and it also need is to because when you are creating this reducer, this function that is going to now update that based on particular cases, okay, this something requires a lot of ceremony, and sometimes you can make some errors. So the value proposition of Redux or RTK say, hey, you know what? Instead of us, all right. Let us now, when you need to mutate the state, as well as to handle cases, we're gonna give you now a builder notations that allow you to do that. So it's going to now it allows you to write JavaScript code, mutable JavaScript code, normal mutable JavaScript code, but behind the scenes we are doing is now this immutability state updates. So what in the F is immutability, and why you need to actually do that kind of things, okay? Because another programming paradigm. So the object-oriented programming realized over the course of the years, realized that mutating the state of an application is something that can cause problems, unexpected problems. It's a nightmare. All of this rippling effect through your entire application is something that is not desired, and then you have to keep track and what. No. So functional programming say that instead of actually you mutating the state, okay, which is another approach when it comes to build applications, because now when you're building application with this object-oriented programming, you are now facing this problem, okay? So instead of you mutating the state of this object, let's going to generate is a new state for that, right? So one of the things that functional programmer, according to Kyle Simpson, mentioned is that one of the main role of software or functional programmers is to try to identify where a bug will happen and avoid that by using the patterns that where they can happen. So that is quite interesting, because we know that a particular error can happen is when you mutate that state. And one of the things that functional programmers say, no, it's going to return is a new state out of that. So this is something that we can do in JavaScript. So by actually using the spread operator, right, you can now create a copy of these objects. And if you want to create deep copy of the objects, well, you have to do that manually. All right. And per each one of those levels, when you want to update the property at those particularly level in the objects, you can do that. This is something that is error prone. Okay. And one of the things that immutability in this particular context means is not that the data won't change. It's not that you freeze that. No. It means that needed change needs to occur with intent. So we need to have ability to keep track of the state change in these objects. So because there are two main type of main two type of immutability. Okay, so you have now assignment immutability, which is using the cons most of the time, according to Kyle Simpson and also my small experience, is say that most of the time we don't care about the assignment here. Because if we define our assignments in a particular piece of block, and that block is small enough, and this only gonna live here in this block, so one of the main problems is that when we are passing data, especially by reference, so because data or values are portable, they can be in any place, here and there. It can go through your third-party libraries and come back here, because data is portable. We need to find a way of how can we now remember a functional programmer, how can we now try to prevent that those happens occur, and what are the practice that we need to apply. So it means that in the case of value immutability, which is another type of immutability, that actually what we really care about here is that we can define, okay, using the object of free as a way to notify the author of the code, hey, this object is just read only, right? And similar, when you are going to receive that data from a function argument, as from a parameter, a function parameter, when you receive that, you want is to create a copy of that. So you are going to assume that the data that you're getting is read only, and then you're going to generate a new state of that. So why this is important and what are the benefits of this particular approach, okay, is like now we have the ability, when we need to pass read only data, we can make sure that the data that we're passing is just a copy of that, or we are not going to mutate that data. So if a program is just only read only, well, that's a program that pretty much is useless. So it's like reading newsletter. Yeah, okay, I read this newsletter. Yeah, I get all of this information. So what I can do with this paper, right? At least with the material, right? My dog is actually about to discharge in my carpet. No. So again, this is an analogy from real life, but in the digital life or in our application here is like, well, if we can mutate or if we can change the state of an application, well, that will be a very, very boring app, and we're instantly gonna delete that. Because of that, because there are some times that we need to mutate the state of our application, right? So we need to find a way of how can we now is make this make this data mutable, immutable. Let me rephrase that again because I know that it's quite confusing. How can we make a mutable data to be an immutable data? So how can we now make a data, mutable data, right, to know when a change, a needed change, happens? That's why immutability, according to Kyle Simpson, is all about controlling mechanisms. It's about to know what happened when actually you mutate the data. So there are the Facebook engineers, again, they found this particular problem and they create now an application called is Immutability GS, I think it is. Immutability. That's how we deal effectively with value mutation. Okay. Okay, JavaScript. This is light functional light. Okay. Exactly.
Is an API to access it. Of the we only step up. You should start by asking, is this ever going to need a structured mutation? Because it's really strange. When you need a mutable data structure, what you actually need is an immutable data structure.
You know, that's and it is quite because you are playing is with words. You're playing is with you're playing with words, and when you play with words in context, that's when people started to trip around, you know, especially when this assignment immutability and value immutability, especially with the cons. That's why now in Java, oh my God, the Java community say, you know what? Because this is quite strange, because this is immutability, and immutability in this context is something completely different to what we as human perceive immutability. Okay, they create is a keyword called final, bro. Oh my God, to say, hey, this is the final value that you are assigning to this, and it won't change, bro. Be mindful about it. Okay, so yeah, we got this immutable data structure. So as I mentioned before, is that what happened when data that need to change? What happened when you need
because it's
Yeah.
really strange.
It's like
When you
when you need, because it's needed here. So when you need a mutable data structure, when you actually need an immutable data structure. Holy hell. And remember that after all, the whole point of this immutable data structure is that needed change needs to occur with intent. So that's why Kyle Simpson's also so far, according to his knowledge and experience, is that yeah, we need to now talk about some sort of controlling mechanism here, as he mentioned.
need a mutable data structure, what you actually need is an immutable data structure. So what am I talking about here? What do I mean by that? An immutable data structure is one that allows not no mutation, but rather structured mutation.
Interesting. Ones that is not allowed value mutation, is allowed structure mutation.
Structured, controlled, intentional mutation.
Jesus. Now this is the big one. This is for big boys, bro. Big boys. Okay. Exactly. So the problem that immutable data structure wants to solve is the ability to keep no. Yeah, you can say that. So what to do when you need a mutable data structure to be an immutable data structure. So that's why immutability is not about assignment
As not no mutation, but rather
exactly. That's why immutability is not about not mutation, but rather structure mutation. Yeah. So needed change needs to occur with intent.
structured mutation. Structured, controlled, intentional mutation, as opposed to just willy-nilly make an assignment statement and create a side effect somewhere. It's the next level from a read-only. You should...
So it's the next level of a read-only.
Start by asking, is this ever going to need to mutate in any way, shape, or form? If so, then I don't use a read-only. I need to do something immutable. But if it never needs to change, then just stick with the plain, simple read-only data structure. We only step up to this immutable data structure if it needs to mutate. So what exactly is an immutable data structure? It is a representation of the data structures that we are used to dealing with. We're used to dealing with data structures like arrays, where we can access things at index positions. We're used to dealing with things like objects, where we can access things at named property positions. It's things like that. It's data structures like that. But where you don't have access to the actual underlying data structure, what you have only is an API to access it. And the API creates a layer of control that prevents unexpected changes to the data structure.
Holy hell. So immutability here is important to understand the problem that it's solving.
Data structures like arrays, where we can access things at index positions. We're used to dealing with things like objects, where we can access things at named. We're used to dealing with data structure. So what exactly is an immutable data structure? It is a representation of the data structures that we are used to dealing.
So, oh my God. So what is? So what is a immutable data structure? And I think this is something about is structure. Yeah, so what is an immutable data structure? Is a representation of an object, okay, that expose an API,
with. We're used to dealing with data structures like arrays, where we can access things at index positions. We're used to dealing with things like objects, where we can access things at named property positions. It's things like that. It's data structures like that. But where you don't have access to the actual underlying data structure, what you have only is an API to access it.
Exactly. So it's a representation of an object that provides an API responsible to mutate the value. Responsible it's a representation of an object that provides an API responsible. Why not? Responsible Jesus. Okay. Proofread the following sentence. Jesus. Responsible. Oh my god. Responsible, okay, to mutate the value. It's a representation of an object that provides an API responsible to mutate the value. Layer upon layers upon layer of abstraction, bro. Oh my god. Software engineer living in a hell of abstraction. Jesus. Oh, F me. That's why you need to touch ground at some point, you know, especially if you're gonna deal in this landscape of abstraction. Oh my, French those guys. But this is interesting. So what is an immutable data structure? It's a representation of an object that you're used to, and a representation of an object that you are used to work, with. It's a representation of an object that you're used to working with. So you got an array, a set, a map, an array, or an object, right? That provides an API responsible to mutate the value. So you are not going to mutate the value. It's this mechanism that is going to do that for you in a way that you can now have observability of this state change. That's quite interesting.
And the API creates a layer of control that prevents unexpected changes to the data.
And the API creates a layer of controls that prevent you from mutating directly. But that prevents unexpected change to the That prevents unexpected mutations in your data. Interesting.
Data structure. Specifically, what an immutable data structure says is unless you switch it into a special mode that allows this. So by default, it's not. If you switch it into a special mode, you can literally go in and muck with it if you have like a performance problem that you need to deal with. But in the general state, an immutable data structure says, essentially, you cannot change the data structure. You can only create a new data structure with the change having been applied. Similar to what we did a couple of slides ago when I made a copy to the thing and then I added the status field to it. It's similar to that concept. It says, listen, I need to add something to it, and the response from the API is, okay, but here's a new data structure with the change applied. I'm not going to let you modify the previous one. And the reason I'm not going to let you modify the previous one is that somebody else in the program might be relying upon the previous state of that object. They have to opt in to saying, I want your version of the object. You don't get to decide, process order, that you're going to affect something at a distance somewhere else in the app. You could return the new order, the processed order with the status field, and allow the caller of your function to decide what they want to do with that information. But you don't get to mutate it from afar. That's what I mean by saying that an immutable data structure creates a control mechanism. It creates a controlled, intentional way for the mutation to occur. And by default, it simply says, let's make a whole new object. A whole new array, a whole new list, a whole new object, a whole new map, whatever the data structure is, make a whole new one of those with the change having been applied. Now the question becomes, how could that possibly be performant? How could it possibly be performant?
Yeah, completely. It's like, so that prevents unexpected mutations in your data. So consumers can have access to a previous version of your data if they need to. Right? Exactly. The question is how that can be performant. You know? How can that be performant? It's a good question. A very interesting one as well. How that can be, how can it be performant? Right? Because it's like, the hell in the French toast is this?
Performant for me to make a whole new copy of this array or a whole new copy of this object every single time I need to make a change. Because the kinds of objects and arrays that we're talking about that need to be mutated probably need to be mutated a lot. Not once or twice, not 3 or 10 times, but like thousands of times a second. So the ante is high for if I'm going to change this thing over and over and over and over again so often, and I'm creating all these new ones and throwing all the old ones away. At worst, at best, I just have a bunch of garbage collection. But at worst, you consider all the CPU churn of making all those copies over and over again.
Mm-hmm. The CPU
and this is where the real power of an immutable data structure comes in. Because the way immutable data structures are designed is designed specifically with this optimization in mind. In theory, in functional programming, we
Okay. So how can it be performed? How by creating a new copies of the data cannot affect the performance. This is the reason why immutable data are so powerful, because it was designed for that. This immutable data is so powerful because it was designed for that.
just say, no, you don't make a new thing, you don't make a change to a thing, you make a new thing with the change applied. But in practice, that means real cost like garbage collection and CPU. And so it is the job of an immutable data structure to mitigate that real practical cost so that we get closer back to the theoretical benefit of what an immutable data structure is. So if you use an immutable data structure, what it's actually going to do is not create a whole new copy of the object when you try to change a property, but rather make a new object with the new information in it and internally have a pointer back to the previous one.
Mm-hmm. Okay, exactly, because it's like
Whole new copy of the optical benefit of what an immutable data structure is. So if you use an immutable data structure, what it's actually going to do is not create a whole new copy of the
mm-hmm. So if you are using an immutable data, which is something that we're using behind the scenes through Immer, okay, which is this convenient way of creating this new state of our application, or create a new state with a new copy, okay. Yeah, it allows to create is a new copy for that, but behind the scenes what it's doing is that it allows to create a new copy of this object in a mutable-like syntax, like doing in JavaScript, okay, like normal JavaScript. There is a lot of inner mechanism going on here, and to me it's like
the object when you try to change a property, but rather make a new object with the new information in it and internally have a pointer back to the previous one. Copy of the object when you try to change.
Okay. So if you're using an immutable data, it's not creating a new copy. Okay. It's not creating a new copy when you are trying to change it. If you are using a immutable data, it's not creating a new copy when you're trying to change it.
Change a property, but rather make a new object with the new information in it.
But rather make a new object with the new information with it, and create a link or create a reference and internally
have a pointer back to the previous one.
Exactly. And internally have a pointer back to the previous one. Holy moly. God damn. And internally have a pointer back to the previous one. Okay.
It's actually a little bit like a Git repo, where every time you've committed something, you're just storing a diff compared to what it was before.
It is like Git. It is like Git what? Git log.
It's actually a little bit like a Git repo.
It's actually like a Git repo. When you see that every time you commit,
where every time you've committed something, you're just storing a diff compared to what it was before.
Exactly. It's like a GitHub. It's like a Git repo. When you commit something, when you commit something,
It's actually a little bit like a Git repo, where every time you've committed something, you're just storing a diff.
okay, so when so every time you commit, every time you have committed, every time you have committed something, you have a you store a def. So you store a diff. So every time you commit, every time you commit something, you store a diff, okay?
Compared to what it was before.
It's like to store a diff and compare to what it was before.
An immutable data structure is essentially conceptually like a Git data structure, where each new object in the chain that you've created is just a diff on the previous object. It stores internally that there's now a new property, or that a property's been changed, or something like that. And so you're not paying nearly as much of the performance penalty CPU, and you're not paying the garbage collection penalty. In the general sense. There's certainly corner cases here, and it's why immutable data structures can allow you to opt in, for a time period. You can sort of crack it open, make some changes, and then lock it back together. Those things have to exist because sometimes we have performance bottlenecks that we need to deal with. But in the general sense, we want to just use the data structure in that conceptual way and allow it to abstract away those performance optimizations for us. So, how do we get immutable data structures? We do not, at the present time, have immutable data structures natively in JavaScript.
How can we use it? Natively, we don't have it right now, 2020. It is just a discussion at the TC technical group, the TC commit, where when we hear things like that, it is something that might take a decade. Perhaps it might take a decade. That might take a decade.
There have been a couple of rumblings from some people on TC39.
Couple of rumbling, okay. So it's just it has been there has been a couple of rumbling with the TC committed TC39 and with the TC39, the TC39, which is the technical group. Oh, I get it. Specifying JavaScript. God damn it. Temporal. Decorator metadata arranged from async. Timestamp canonization. See proposal in all stage. Okay, temporal. Well, who knows? Now thing is going to speed up vastly, bro. Redeclarable global eval here. Math some precise. function.send meta property throw record and tuple. Async context. Async context. Jesus. Extractors. Oh shit. Again, this is very not specific problem to this. Interesting. Legacy regex JavaScript features, JSON parsing, source text access. Floating 16 on type arrays. They started to realize that they need to redeclare global eval, introduce var. Anyway, what is this? A technical commit 39. So there has been a couple rumbling with 39 commit. But when we hear that
maybe someday that will happen. But you need to
that maybe that's something someday will happen. When you hear when we hear things like that,
understand that when somebody says, oh yeah, you know, somebody on TC39 has talked about maybe it happening, that means that we might get it a decade from now. That's not like, oh, it's going to happen in a few weeks or a few months. The timelines that we're talking about here are, oh, it's been talked about for the last 5 years, and now there's like a first proposal, and then 4 years later they vet it, and now, you know, it's finally landing. So we're not talking about this sort of stuff landing natively in JavaScript anytime soon. But it's at least encouraging that some conversation has started about it. Some people in that realm have started to say, maybe this would be useful for JavaScript to have built in natively. And there would be a huge benefit to the language being able to highly optimize these sorts of things that we're talking about.
Damn, son.
In the interim, in any place where you have a data structure and it is important for you to manage the mutations to that data structure, you're going to need a library that provides you an immutable data structure. And there are a couple of major ones out there that you will hear about. Probably the most common of those is called Immutable.js.
Again, this proposal introduced two new deeply immutable data structure to JavaScript. Record and tuple, a deeply immutable object-like structure, and a deeply immutable array-like structure. Holy moly, bro. Records and tuples can only contain primitive and other records and tuples. You could think of records as tuple as compound primitive by being through wholly based on primitives, not objects. Records and tuples are deeply immutables. Record and tuple support comfortable idioms for construction, manipulating and use similar to working with objects and array. They are compared deeply by their context rather than by their identity. JavaScript engine may perform certain optimization on construction, manipulating. Okay. Today, userland libraries implement similar concepts like Immutable.js. They actually put in notes in that. Also, previous proposals have been attempted but abandoned because of the complexity of the proposal and lack of sufficient use cases. Immer is a notable approach to immutable data structure and prescribes a pattern for manipulation through producers and reducer. It is not providing immutable data types, however, as it generates frozen objects. This same pattern can be adapted to the okay, because it's generating frozen objects. It generates them at runtime. The proposal. You're going to define now an immutable data structure with the data, okay, followed by this. Tuples are primitive type. Tuples are primitive type, so you can put them in records, okay. So accessing keys like you will with objects, okay. And if you want to now spread like objects, or now provide is a change in this, So you proposal, mutate that, or pass the mutation to that. And then when you want to take at least at this proposal 2 with this new change, you're going to have that. As well as this. Object function work on records. Content. Oh, exactly, on records. So you can look at the properties of that object. Oh, crap. Again, this is part of the specifications. That's very interesting. That's very goddamn interesting. Oh my god, the object model recording. Oh my French toast guy. So this is the way of how you're going to define is this data is immutable. Whether it's by a record or by a tuple. Oh my god, that's quite interesting, bro. Again, this is just a proposal. This is just a proposal.
Comes from the folks at Facebook. So if you
Okay. So we can use is immutable.js from the folks of Facebook. And again, all of these engineers, they are building that because they are solving their own problems, bro. They're not doing for charity. They're doing they're doing, I will argue, I am not one of them. That'll be interesting if they can agree with me with that or tell me no, it's not what you think it is. But it's because they have a pain, they have that emotion, and they use the reason as a way to come up with that, right? So the emotion is at the service of the feel. So the reason is at the service of the feeling. Jesus. Okay. Exactly. Also, Imer. Since this doesn't require a new API to learn by having a draft object where you can introduce your chains, Imer after that is done, it will generate a new state of that. So by wrapping an object with an API that exposes some of the method that internally can update the data with a new data, generate a new state, and do it in a performant way. So the idea behind is pretty much like Git, when you add a diff to it. With a proxy object that exposes a method that internally can update the data with new data, generate a new state, do that in a performant way. Holy moly, bro. Jesus.
you want to check out Immutable.js, they've got a bunch of great documentation. It has a huge community around it. It's a great library. There's another one out there that seems to be preferred by people from particular sects of the functional programming community, especially those that kind of come from like the Clojure and that sort of side of our programming community. That's called Mori, M-O-R-I. Clojure script, which is the JavaScript subset of Clojure, the language, has immutable data structures in it. And what they did...
Mori. Clojure script persistent data structure and support API from the comfort of vanilla JavaScript. Efficient immutable data structure. No cloning required. Uniform iteration. Oh, Okay. Mori. There are other libraries out there. Okay, there are other libraries out there from the sect of functional programmers. Okay, called Mori. A library for using closure script, persistent data structure, and supporting API from the comfort of vanilla JavaScript. Mori.
It was extract the MORI. Closure script, which is the JavaScript subset of closure.
Okay, closure script. Okay. From closure script, which is a JavaScript subset of closure, which is a JavaScript subset of closure. This functional programming language. Okay. Closure. It's a general purpose programming language, but a lot of people actually use it for that, for writing in a functional way.
The language has immutable data structures in it, and what they did was extract those immutable data structures into a library, and they released it called Mori. It has a different take on the way that it works and what the API looks like, but same general end goal, which is give me structured mutation on my data structures. So here's an example. I created an immutable list of a couple of things. Now, it doesn't really matter whether those things like textbook and supplies are strings or objects or arrays. From the level of the data structure, the outside, all we're saying is the presence of those in this list is what is immutable. If those things were objects, then they would still be regular old mutable objects. So if you want to have deep immutability, you want to prevent one of those sub-objects, then you're going to need to use immutable data structures at every level. But I left it sort of deliberately general here. We don't know what textbook, supplies, and calculator are. But at this point, that's not our concern. They could be immutable JS objects or maps or something like that, or they might just be regular old plain objects or strings or numbers or who knows whatever. But the point is line 6, when I say dot push on an immutable data structure, an immutable list, it's not going to actually modify that list the way it would have with a normal array. Instead, we're going to get back a whole new object. That's called updated items. And that new updated items object has all the same stuff as the previous one, plus the new object having been added. And that's why items.size is still 2. It didn't get changed in any way, shape, or form. It is an immutable data structure.
No, make it public. That's quite interesting. God damn it. Hello for Codesandbox. Okay, damn, son. That's quite interesting. I just want to test this, bro.
And internally, they've taken care of the optimization to have the pointer to be where it needs to be. So let's review what we've talked about here. We started by talking about
Immutability.
the idea of assignment mutability.
And then
Generally speaking, we're talking about the const keyword and whether or not it's going to provide the benefit. Usually, functional programmers try to minimize the amount of assignments anyway, so it probably shouldn't be the case that you have very many of those declarations. But for the ones that you do have, you're generally going to be doing them inside of small blocks, and the const keyword is not going to provide much benefit for you. So maybe it's more appropriate to use a var or a let in those places, just so that you don't trip up the reader of your code. My rule is not that I don't use the const keyword, but that I use the const keyword only for things that are already, by their very nature, unchangeable, like numbers and strings. So I'm fine if you say const base price equals 6, but don't ever, please, at least in my opinion, say const ARR equals and then use an array, because that is inviting the reader to get tripped up. The real point that we should be focusing on is the value immutability question, and we have two different ways, actually 3 ways to use an array, strings. So I'm fine if you say const base price equals 6, but don't ever, please, at least in my opinion, say const ARR equals and then use an array, because that is inviting the reader to get tripped up. The real point that we should be focusing on is the value immutability question, and we have two different ways.
Yeah, that invites to the reader to trip up. Yeah, because it's about assignment immutability, which means that you can reassign the value of this. So the value of this, oh my god, you are tripping it. You are invited to tripping it. You can so you can assign. So you can say something like this. You can define here's an array that we're going to contain is ID 1, the name John. Okay. Yeah, you are invited to the reader. You're invited to read it. You're invited to trip in the reader. So though, right? Okay. So you are doing is now is assigning immutability. You can assign is this array with a new value, but you can mutate that. So for example, by saying is hey the 0 position, the name I want to change that to Arthur. And he'll do that. And when you want to take a look at this new array, okay, it's a hey, we already mutate the value. That's not a good deal, bro. That's definitely not a good deal, bro. Okay. You know, that's actually not useful.
Actually, 3 ways of thinking about that problem. One way is, at the call site, when we're going to pass in one of those data structures, we should annotate it with something like object.freeze to say to the reader, don't worry about it, it can't be changed. And if you need to do sort of a recursive object.freeze thing, make yourself a little helper and just use that helper everywhere. You know, use the little helper called read-only that you pass in an object and it traverses an object and makes it deeply read-only. That's great. Whatever you need to do to annotate to the reader, they don't need to worry about that thing changing. Secondly, when you receive a data structure, no matter what, assume that it should be read-only. And lastly, if you need to actually track changes to data structures, that's what you should be doing with an immutable data structure. Immutable data structures are ones that need to be mutated. That's what we have to rewire our brains to think about, because we usually think about
exactly. Immutable data structures are data that need to be mutated.
About immutability as it's not going to change. And what we really mean here from a functional perspective is it's things that need to change, but need to change in a controlled way.
That's all. So exercise, please.
All right, let's try an exercise on this topic of immutability. Get some practice with
Please.
both assignment immutability as well as value
Get
immutability,
ready.
and of a couple of different kinds. We'll look first at read-only data structures, and then we'll also look at not changing a data structure that's been passed into the function. This exercise won't be covering actual immutable data structures like Immutable.js, but hopefully these concepts will transfer into working with something like Immutable.js. First at read-only data structures, and then we'll also look at not changing a data structure that's been passed into the function. This exercise won't be covering actual immutable data structures like Immutable.js, but hopefully these concepts will transfer into working with something like Immutable.js. Okay, in this exercise, you're going to be generating a set of lottery numbers. And because we're doing generation of lottery numbers, of course, it's random generation. The goal here is to make everything else pure except for that call that is doing a random number generation. We want to leave everything else using all of the principles that we've learned so far in the course about function purity. So if I switch over to the exercise file, you'll notice that we have a function that does the generation of a random.
Nope. Can I do this? Oh my god, long life to the drag and drop, bro. Oh, that's pornographic. Long life to the... Yeah, replace that bitch. Jesus. That's pornographic, bro. That's definitely pornographic. Okay.
Lottery number. That's okay that that one is impure, but we want to leave everything else according to our principles. So we're going to fill out a definition for a pick number function, and you'll notice that I have a while true loop there that's supposed to pick a number and stick it in some way into the lucky lottery.
You take a pick a number function that you're going to then create a collections of numbers, lucky numbers, okay, and give if the length, okay, the lucky lottery numbers in an array, okay. So if we have less elements, right, like that, we want is to now is pick a number.
Numbers array. Now that is pretty easy. We could just stick the numbers in, but the README details a set of constraints. First of all, we want no duplicate lottery numbers. Now that's not all that likely that you would randomly generate the same lottery number, but we want to ensure that they are no duplicate, so we want to have unique lottery numbers. And also additionally, we want our pick number to make sure that lucky lottery numbers always stay sorted in ascending order. So essentially what you're going to want to do is have pick number generate a number and stick it into the lucky lottery numbers list if it's not already there, and then make sure the list is sorted. Now, keep going to do is have pick number, generate a number and stick it into the lucky lottery numbers list if it's not already there, and then make sure the list is sorted. Now, keep in mind that if pick number calls lottery num directly, that makes pick number not a pure function. Make sure the list is sorted. What you're going to want to do is have pick number, generate a number and stick it into the lucky lottery numbers list if it's not already there, and then make sure the list is sorted. Now, keep in mind that if pick number calls lottery num directly, that makes pick number not a pure function. So remember what we talked about extracting impurity. We don't want to embed the impurity if there's some way to extract it. So keep that in mind also with the exercise.
Okay, not sure what we're gonna, okay, I'm not clear what we need to do here. Define pick number, so that is a pure function. It should the list of lottery numbers in a new lottery number, randomly generated using lottery num, to add to the list, okay. Okay. To add to the list. So define pick number, so that is a pure function, and it should the list of lottery numbers and add a new lottery number. So is this. So this is exercise. So pick number here is just actually is Big number should always keep the list of lottery numbers sorted in an ascending order. Also, no duplicates. Hint: array sort with no arguments does not do numeric sorting, but alphanumeric sorting exactly. You will need to pass a custom comparator function to get through numeric sorting. Bonus: instead of read only via object.free, use Immutable GS list data structure to manage the additional lucky notary numbers. But the thing here is that I don't know what this exercise to practice with assignment and value immutability. Define big number, so that is pure function. Okay. Yeah, you're a pure function. It should list the lottery numbers. It should list the lottery numbers. Okay. Big number. It should list the lottery numbers and a new lottery number. So here it should list it's because this is quite strange, this instruction here. Define a big number, so that is pure function. It should list the lottery numbers. Okay, it should list the lottery numbers and add a new lottery number, randomly generating using lottery num. Okay, so that's right. However, if we call this function like so, all right, yeah, if we call this function like so, right? So this is now a function that is going to always, anytime that we call it, it's going to give us is a random number. Okay, so far so good. So what we can do is to say, hey, gonna call the lottery number. So lottery number, okay, lottery number, to get a random number. Okay, to get a random number. Okay, so call lottery number to get a random number. Okay, this data that we're gonna get, okay, is now immutable, assignable, immutable. Okay, so it should list the lottery numbers and new lottery number to add to the list. Should always keep the list of lottery numbers sorted in ascending order also, right? So what we can do here is to not only that, but is to pick number, all right, must add this. So add the new lottery number to the list, right? So far so good. So what we need is to, well, if we want to make this a functional or a pure function, okay, let's keep this in pure function, okay, all right. So the whole point of this is to receive everything that this function needs, and in this case the first parameter is the lottery num function, right, as the first arguments, and then we're going to receive now is the lucky lottery nums, right? Lucky lottery nums. So once we get this, we can safely say, hey, you know what? This value that we are going to get here, I just want to make the final, which is the number, say lucky number, right? You say, hey, lottery num function, You're gonna call this here because you already received that reference for that, which is great. All right. And because we want is to then is now add that elements sorted to the lucky lottery numbers, lucky lottery nums. But because we want to assume that this data that we're getting is always read only, okay? We can define is now a new data call is a new lucky lottery nums, okay? And here we're going to apply that transformation that we want to, which means is that luckily because this is now an array, okay, and we want to create is a new out of this. We say, hey, one way to do this. We say, hey, luckily lottery nums, which is an array, okay. I want to create now a new array with all of these elements here. This is one way of how you can create that, this deep copy. And then you say, hey, you know what? I want to also add the lucky number here. So once I do this, all right, I want you to now is sort these elements, because this sort is now alphabetically, all right. Yeah, function use is alphabetically. So this function sort is now sorted alphabetically. So you say now mdn sort array, that kind of thing, right? Like so. Yeah, sort of the elements array in place. It means that it doesn't require additionally data structure or additional space, okay. And returns the reference of the same array now sorted. Oh, and exactly, it returns a reference of the same array now sorted. The default sort order is ascending, building converting the elements into a string, then comparing the UTF sequence for that. So this is what is doing this tool, the sorting here, is that it takes these elements, and if these elements are in a string, by default it's going to convert that into a UTF 16 code units and compare that. You know, hey, where is this? Because this is something that we might want to, okay, as long as we generate is okay, as long as we generate is now as long as we generate, oh my god, as long as we generate is now integer numbers, that'll work. But because we're generating is this floating point numbers, it won't work. You know, it won't work. It won't work. It won't work. It won't work, right? It won't work because what it's doing is just comparing that by the UTF. So what it's doing this sorting so what it's doing is this sorting array is comparing this element that is on a string and transforming each one of those characters as a UTF 16 code unit. So you have now a huge code unit of where now each one of those symbols has a unique 16 code unit, right? And you have now the alphabetic or the Latin words from A to Z, and then you also have another section from the Arabic number from 0 to 9. Yep. but because we want us to compare now is sorting non-asking characters. Sort returns the reference of the same array, which means that if you mutate that, you're going to mutate that array, so you don't want that. Since version 10's ECMAScript 2010, the specification dictates that array.prototype sort is stable. It means that order matters. Sorting with non-well-formed competitor. Exactly. In comparing function does not satisfy all purity, stability, reflexivity, and symmetry and transitivity rules, and explain the description. The programming behavior is not well defined. For example, this code, the compare function here is not well formed because it does not satisfy the anti-symmetry here. A is greater than B, returns 1, but by swapping A and B, it returns 0 instead of a negative value. Therefore, the resulting array will be different across engines. Sorting with a map. The other is sorting array objects, creating, display, and sorting arrays. And the other is this compare function. To memorize this, remember that A and B is equal to A minus B, sort numbers in ascending order. Okay. Let me do this here. Right. So to compare numbers in ascending order, pass this callback function here. Okay, that is ascending order. You can define here like that. Comes ascending function, ascending order function, like that, and then I say is just to remember that. So A and B, this parameter that you're going to receive is A minus B, right? So this is ascending order. So in an ascending order. So call that, please. And well, what you to return is that this new lucky number as it is. And of course, we need to pass this the reference here, the lottery num. That's right. We are passing this as reference, okay? And as a way to indicate that, hey, I don't want you to mutate this object.freeze. This is read only and similar to the numbers. Okay, to the object dot freeze. Hey, this data that I'm passing here is read only to help the reader of the code reader actually understand the intent of this code. Crap. So this is now lucky lottery numbers here, and then it's going to actually print that as it is. So now that we have this, and if in our particular case we want us to now run or import this, like so, on the index we can say is, hey, I want you to L. Import. Why you are not using this import statement here? That's quite interesting. Of the file called X here, right? And because I'm not exporting anything here, which is use a strict, which is hey, let me wrap this function here called is exercise, where you say immutability, immutability exercise. Okay, so you do things like, hey, something like this. All right, I'm going to add some padding here as a way to understand what we're doing. Oh, the French stuff is this. What? Okay, that's right. So now I want you to export this function, export default this function. All right, so I can now make use of this here. Now I can, yeah, immutability exercise. When I say, hey, immutability exercise, and I want to call this function here, you know, I want to call this here as a way to run this as expected, right? Cannot use import statement outside of a model. Is I cannot use import outside of a model. But this is because of the import. Yes, there's a model here. No. It's a import. To load an ES model, set type model in the package.json or use the mx.mgs extension. Well, that's what I'm doing. It's like you're not actually detecting that. Well, anyway, the type here, type, which is the type model. Say, hey, model, please be my guest. That's right. Please accept that. Don't complain. You gotta be freaking kidding. But that's funny. It's like you don't detect that. Anyway, I don't want to I don't want to fight with you, man. No, I don't want to fight with you. Hello. var this one from this. This is how you want to play. All right, no problem. Take care. No, man, I'm not gonna fight with name extension, that kind of thing. No. Hell no. Hell no. Exactly. Import that. Import this model. Unexpected token export, of course, because here we need to say is model. Yeah, the model export. Like so. It's a because it must be a function like that? Okay. Because we need to pass this a reference to this. Okay. It is working. Hey, what the fuck? This is now X. X.js. You run this, and that's quite interesting. I try to run this, I run it, but when I run this, so when you to execute this, wow, what the French toast happened here? Anyway, node X.js. Jesus. Okay. Ooh, a freaking look, bro. Oh, but we are not exact. But we are not updating is this one. Locally lottery numbers. You know? Hey, you got it, exactly. Now this work. Okay. Lol. That's interesting. Because here you're gonna pass is the function as a reference. Exactly. And there is no need to actually say, hey, do that. But for the reader, we're saying that it's like, hey, pass this lucky number, okay, execute that. Oh, okay, that's interesting. That's interesting that you're not passing is now function executions to that. You're just executing that and then pass the value through that. That's interesting. Okay, that's quite interesting. That's very, very interesting, bro. That's a very, very interesting, bro. Yeah. Then you sort past the function here and returns the nums. That's right. How many? 6. That's quite interesting. Exactly. The same S, bro. The same S. The same S. That's very, very interesting. That's very, very interesting. with the new value. That's very, very interesting. That's very, very interesting. Okay, that's a very, very interesting. So that'll be all for this video. Take care. Bye bye.